Okay, let's dive in. We're looking at a really fascinating manuscript today from Shawn Ratcliffe. It tackles one of those huge kind of philosophical problems in physics.
Right.
Why do physical fields even exist? Gravity, electromagnetism, the very fabric of everything.
Right. And the standard answers are, well, they're not very satisfying.
Not at all. It's what Ratcliffe calls the problem of brute facts. You basically hit a wall. Either fields are emergent, so they pop out of something more fundamental we haven't found yet.
Or they're just a brute fact. They just are. End of story. Don't ask why.
Exactly. But this paper proposes a third way, which is really compelling. It argues fields are a logical necessity through symmetry.
It's a bold claim. The mission here is really to establish a firm ontological bedrock, to show that the universe's structure doesn't just allow for fields.
It demands them.
It demands them.
Yeah.
And the entire argument, the empirical ground for it, rests on something we know works, Noether's theorem.
Okay, so let's start there.
Simply put, the theorem proves that if you observe a conservationist CAC, law-like energy is always conserved, or momentum is, then there must be a corresponding differentiable symmetry in the math that describes the system. The observation of the law guarantees the existence of the symmetry.
And this is where it gets really cool, because the paper ties that mathematical certainty directly to physical things. It says fields aren't just, these passive occupants of space-time.
No, not at all. They are the dynamical manifestation of those symmetries.
So the symmetry is the rule book, and the field is the entity that actually carries out the rules.
Precisely.
Yeah.
And since particles are just excitations of those fields, little wiggles on them, the symmetry in the field become, as he puts it, functionally entangled.
One can't exist without the other. The symmetry needs a domain to influence, and the field provides that domain. It's a package deal.
It is. And this functional entanglement is what leads to the central claim. If a symmetrical universe is a given, because we see the conservation laws, then fields are a logical requirement of that system.
Okay, but I have to ask the obvious question here. The brute fact objection. Aren't we just kicking the can down the road? We stopped asking why fields, and now we're just asking why symmetry.
And that's the most critical distinction in the whole paper. A brute fact, he argues, is a choice of nature, an arbitrary fact, like the mass of an electron.
Right.
But symmetry isn't a choice. It's a constraint of consistency. It's part of the logical framework itself.
I see. It's that analogy he uses, right?
Yeah.
You can't have a symmetrical universe without fields, just like you can't have a triangle without three sides.
Exactly. The structure demands its components.
The sides are a necessary consequence of defining triangle.
And this is where the framework sets up what it calls a terminal boundary. The chain of why questions has to stop somewhere, and it argues it must stop at symmetry.
So if you ask, well, why does symmetry exist?
You're no longer doing physics. You're stepping into metaphysics, introducing ideas outside the closed, observable system. He calls that point semantic satiation. The question just stops being meaningful.
So the big takeaway here for you, the listener, is pretty profound. The universe looks less like a random collection of things that just happen to be, and more like a self-consistent mathematical proof. The math, the symmetry, isn't just a description of reality, it's the requirement for it. And the existence of every single field we know is just the logical fallout of that structure.
Which leaves us with a really provocative thought to chew on.
Go on.
Well, if the existence of fields is truly logically mandated by symmetry, what does that imply for the future? If we ever observe a completely new fundamental conservation law, does that mean we've also simultaneously proven the pre-existing non-negotiable existence of an entirely new quantum field just waiting for us to find it? If the law is there, the field must be too.